Hello, my friends. Congratulations again for completing part 1 data preprocessing. You are now ready to build machine learning models, and the first models that we're going to build together are regression models. So welcome to part 2 on regression. This is the branch of machine learning that aims to predict some continuous real numbers, like for example a salary or a temperature or any kind of continuous numerical value. And together we will build the best models to make these predictions. And so now, first of all, let's make sure we're all on the same page. This is the whole machine learning A to Z folder containing all the codes in Python and R and the datasets. Part 2 regression, there we go. There are several sections inside, each section corresponding to a different regression model. We're going to start with simple linear regression, which is the simplest machine learning model you could ever build. And so it's good that we start with this, because indeed with this one, we will only have one independent variable, one feature, and of course, one continuous real value to predict. Then we will move on to multiple linear regression, which is based on the same equation than simple linear regression, only this time we will have several features instead of one. Then we will move on to polynomial regression, which will allow us to tackle some nonlinear data sets, data sets with nonlinear correlations, as opposed to the two previous models, simple linear regression and multiple linear regression, which can provide some amazing and accurate predictions for linear data sets, data sets with linear correlations. Then, after polynomial regression, we will move on to support vector regression, which is another kind of nonlinear model that can make some accurate predictions for nonlinear datasets with nonlinear correlations. And then finally, we will move on to decision tree regression and random forest regression, which can provide an alternative to predict an outcome for nonlinear datasets. So you'll have many options. After this part 2, you will have basically a toolkit of several regression models. And so whenever you end up with a new dataset where you have to predict a real continuous outcome, well, you can just try all of them and select in the end the one that has the best accuracy. And thanks to the code templates that will result from each of these sections, you will get very clear code templates that you can adapt to your own datasets so that you can try these models on your own datasets in a flashlight quickly and efficiently so that you can select the best one, giving you the best accuracy. And so now in this first section in regression, we're going to start with simple linear regression, of course. So there we go. Make sure to go inside this folder. We're going to start with Python. So let's go inside this Python folder and you will find inside two files. First, the dataset salary-data.csv, and of course our Python implementation, which has the IPython notebook format, which I remind you can run on either Google Colab or Jupyter Notebook. And of course, we're going to implement this model together on Google Colab. But first, let me explain the dataset and the problem that we're going to solve with simple linear regression. And to do this, I'm going to open our dataset here and explain what this is about. All right, so first, I want to reassure you that indeed, this is a very simple dataset, with only 30 observations. And of course, in real life, the datasets are more complex, but I want to start working on a simple dataset so that we can really focus on how to build the model itself, because if we had a complex dataset, we would lose a bit our focus on the model. And I really want us to focus on the model. So let me describe the dataset. It is a dataset containing, as you can see, 30 observations and 2 columns with, of course, one feature. This is the feature, years of experience, and the dependent variable which we want to predict, which is the salary. So let's say that this dataset belongs to a company that gathered data of some of their employees, collecting for each of them their years of experience and their salary. So you see, each row of the dataset here corresponds to different employees, corresponds to one employee of the company. And for each employee of this company, we have indeed the number of years of experience in the company and their salary, okay? And so the goal, very simply, is to build a simple linear regression model that will be trained to understand the correlations between the number of years of experience and the salary, so that it can predict for a new employee, having a new number of years of experience, well, the corresponding salary or the salary that this person should get. So you see, that's a very easy problem, but at least you'll know how to build a simple linear regression model and perfectly master it in all the detail. And then I want to say something very important. Remember that we're going to build each time some code templates which you can adapt to your own dataset, so that when you want to use the code template on your own dataset, you will only have one thing to change, which will be the name of your data. I will always make sure to make the code templates as much generic as we can, so that you only have one or two things to change when you want to deploy them on your datasets. So great, that's for the dataset. And now we're going to move on to the implementation, Simple Linear Regression IPython notebook, which we're going to open with Google Collaboratory. So that's Simple Linear Regression. Let's see how this implementation is structured. First, we're going to import the libraries. You recognize the first steps of the data preprocessing phase, which we covered in part 1. Second, we're going to import the dataset. Then third, we're going to split that dataset into the training set and test set. Then we're going to train the simple linear regression model on the training set. Then we're going to predict the test set results. Then we're going to visualize the training set results and visualize the test set results. But I don't want to show you this too much right now because I want to keep the surprise for the end. And so what we're going to do now is implement this whole simple linear regression model from scratch together. And to do so, we are going to create a copy of this file by clicking here on Save a Copy in Drive. This will create a new copy on your drive in which you will be able to do some modifications or implement the new model. Now we just have to do one thing. It is to remove all the code cells because we're going to re-implement it from scratch step by step. So let's do this. We just need to click this trash button here on only the code cells. Make sure to keep the text in order to highlight, the structure of this implementation. So there we go. Let's just delete everything here. And one last, perfect. So now we have the whole structure of the implementation. You can clearly see the different steps that we're going to implement together. I will ask you to implement some of them on your own. And of course, then we will implement the solution together. But that's because I really want you to learn by doing. I really want you to take action and try to implement some parts of the models on your own. All right, perfect. So now I want you to think, what is going to be our first step here based on, what we covered in part 1? Well, our first step is obviously the data preprocessing phase, in which we have to import the dataset and maybe use some tools in order to pre-process it the right way so that our future simple linear regression model can be ready to be trained on this dataset. All right, and now I'm excited because I'm going to show you the efficiency of the data preprocessing template and how easy and fast it will be for us to pre-process our dataset here. So what we're going to do now is we're going to go to that previous folder, the data preprocessing folder, which was in part 1 data preprocessing, accessing the Python section. And there we go. Now we're going to open that template. Perfect. And you're going to see we're simply going to do some copy paste, and you'll see that we will only have one thing to change, and then the data preprocessing phase will be ready and done. It will be done for us to move on with the next step, which will be, of course, to train the simple linear regression model on the training set. All right. So now I'm going to show you what I've just said. I'm simply going to do some copy paste here. There we go. To import first the libraries and then adding them in a new code cell. Then to import the dataset, I'm simply going to copy paste this second code cell, and you'll see that I will have almost nothing to change. So creating a new code cell here, pasting it, and finally, let's do that final sub-step of the data preprocessing phase to split the dataset into the training set and the test set to, in order, I remind, have the separate entities where we're going to train separately the model and then evaluate it. So there we go. Let's paste it. And now, as I've told you, we only have one little thing to change, which is, of course, the name of the dataset. And I remind, the name of the dataset is, we're going to go back to our regression folder here, very quickly, part 2 regression, simple linear regression, Python, and there we go, here we are. And as you can see, this is salary underscore data. So the only thing I have to change here is the name of the dataset, and then voila, everything is ready. The data preprocessing phase is ready, because indeed, this takes automatically the features, because it selects all the columns except the last one, and this selects automatically the dependent variable vector, because it selects the last column. So here, of course, we have only one feature, therefore one column for the features and one column for the dependent variable. But you'll see, for example, that for multiple linear regression, it will be exactly the same. We will have absolutely nothing to change here, okay? So now let me show you the beauty of the result. Don't forget, of course, to upload the dataset before, running these cells here. So to upload the dataset, you indeed need to click this folder here. Then it's going to connect to a runtime to enable file browsing, after which you'll be able to upload your dataset. There we go. So you click this upload button here, then you go to, this whole machine learning A to Z folder, which was provided to you in just the previous tutorial, which you had to download if not already. So indeed, we're going to go inside this folder, then we're going to go to part 2 regression, then simple linear regression, then Python, and there we go. We select our dataset, salary data, we open it, and now it is indeed in Google Colab. So perfect. And now we're simply going to execute each of these cells, first importing the libraries, then importing the dataset, perfect, and now splitting the dataset into the training set and test set. And done. Now the data preprocessing phase is over, and we can move on to the next step, training the simple linear regression model on the training set. Okay, my friends, so we just covered the data preprocessing part, and we covered it in Flashlight thanks to our data preprocessing template. And now we're about to really build and train the simple linear regression model on the training set, of course, right? Remember that we splitted the data set into the training set and the test set. The training set will be used to train our simple linear regression model, and the test set will be used to evaluate it. So now we have to start with the training, and so there we go. Let's create a new code cell and let's implement the very simple linear regression model. All right, so the first thing we'll have to do is to import the right class with which we're going to build this simple linear regression model. Because indeed, we could either implement it from scratch or we could use libraries. And of course, we're going to use libraries because I want to provide a very clear code template which allows you to build any simple linear regression models in a Flashlight. And this library that we're going to use is scikit-learn, from which we're going to get access to a certain module called linear model, and from this module we're going to call a certain class called linear regression. And our simple linear regression model which we're going to build will be exactly an instance of this class, right? It will be an object of this class. All right, so let's do this. Let's start by importing from the scikit-learn library, which has the code name sklearn. So from sklearn, then as we said, we're going to get access to a certain module. So we have to add a dot here, and which is linear model. And from this linear module of the scikit-learn library, well, we're going to import the linear regression class. Exactly this one, linear regression. And then, as we said, this simple linear regression model which we're going to build will be an instance or an object of this linear regression class. And therefore here we have to create a new variable which will be exactly this instance of the linear regression class. And we're going to call this object, we can call it by any name, but we're going to call it regressor, because indeed we are doing right now regression, right? I remind the big difference between regression and classification. Regression is when you have to predict a continuous real value, like a salary, as we're about to do. And classification is when you have to predict a category or, a class, which we will do in part 3, classification. All right? So regressor, that's a new variable, which at the same time will become the object of the linear regression class. And you can exactly see this object as the linear regression model itself. I remind that a class allows you to implement a couple of instructions to build something, and well, this linear regression class built exactly the simple linear regression model. All right, so you have to see this regressor object as exactly this model, right? So regressor, and then to create an object of a class, well, there's nothing more simple. You just have to call the class itself linear regression and then add some parentheses, and that's it. Usually there are some parameters inside that we can implement, but here you don't have to enter anything. This will just create the simple linear regression model, and it is so simple that usually we don't have to play too much with the parameters. All right? And that line of code directly creates the simple linear regression model. And that's only the building part. We actually get a model. But now, of course, we have to train it on the training set, and therefore we have to connect it in some way to the training set. And the action, or the function that connects it in order to train it, is called the fit function. Remember this because this is your first machine learning model, so this is the first time you're going to use this fit method, and then you're going to see you're going to use it all the time, whether you're going to do neural networks or anything in artificial intelligence. The method that we're going to use to train our regression model is the fit method. And how do we call such a method? Well, first we have to take the object itself, regressor, and then add a dot, and then add the method itself, which is fit, and add some parentheses. So as a reminder, the fit method here is a method of the linear regression class. And I remind also that a class indeed has a couple of not only instructions, but also tools. And these tools are called the methods. And these tools complete some actions like training a model on a certain training set or predicting some future results, on the test set. So that's the first method, and you'll see that then we'll use another method. All right, so basically, this fit method will train this regression model, the simple linear regression model, on the training set. And now, as you might guess, the only thing that's missing here and that we have to enter in the fit method is, of course, the training set itself. However, we have to enter it in a certain way because the fit method expects a certain format of the training set. And this format is, of course, the couple of X-train and Y-train. Right? I remind that X-train contains the features, the independent variables of the training set, and Y-train contains the dependent variable vector of the training set as well. And the fit method here expects exactly the training set in this format, with first the matrix of features X-train, and second the dependent variable vector. X-train and Y-train, just like that. All right, so now what I suggest is that we run all the cells because we haven't run any cells so far. So we're going to do it because indeed when we're going to run the cells, something will happen in the output. So let's see. First, we have to import the libraries where we import NumPy, Matplotlib, and Pandas. Then we import indeed the dataset. Make sure to have it uploaded in Colab. Then step 3, we were going to split the dataset into the training set and the test set. So there we go. Now we have X-train, X-test, Y-train, and Y-test. And since we have X-train and Y-train, well, we can now train the simple linear regression model on the training set by calling this fit method taken from the regressor object of the linear regression class. Here we go. Let's play this cell. And as I told you, there is something in the output. That's just to say that indeed the linear regression model is created. And that's the default parameters. You don't have to worry about them. But there you go, congratulations! You actually built and trained your very first machine learning model. I'm super excited for you. I remember how excited I was the first time I did this. So there you go, I know the feeling, but be aware, my friends, that this is the first, but definitely not the last machine learning model that you're gonna build. We're gonna build many others, more complex, of course, and for any types of applications. So, by the end of this course, you will know how to do anything in machine learning. And that's why we really want to provide code templates for you to be efficient on how to play with them. Okay? So, congratulations again. Now we're going to proceed to the next step, predicting the test set results. And for this, we're going to use a new method. And so now I would like you to take action. I would like you to try to predict the test set results before we do it together. And I'm going to give you a little hint, even if you can look at it online. Well, the method that you have to use to predict new observations is the predict method. As simple as that. They chose some simple terms. So there you go. Try to implement that before me. That's your little exercise here. And we will implement the solution together. So based on what we've just done in the previous tutorial, when training the simple linear regression model on the training set, and also based on the hint I gave you, this predict method, well, you should have been able to crack this. All right, so now we're going to implement the solution together, starting by creating this new code cell. All right, so first let's just explain what we want to do here. We want to predict the results of the observations in the test set. And so let me show you once again the data set. So that's the whole data set containing the 30 observations. And we actually split this data set into the training set and the test set the test size was chosen to be 0.2, meaning that 20% of all these observations went into the test set. So 20% of 30 is actually 6. So let's say, just to simplify the explanation, that the observations of the test set are the last 6 ones, 1, 2, 3, 4, 5, 6. So let's say all these observations went into the test set. Well, what we want to do now is predict for each of these observations, meaning for each of these employees, the salary, right? So what we're going to input in that predict method is exactly the number of years of experience for each of these 6 employees, and our model will predict the salaries. So the salaries that we see here, the last 6 ones are the exact salaries, the truth. We call it the ground truth. And when calling the predict method on these 6 numbers of years of experience, we will get 6 predicted salaries. And so what we'll want to do then will be to compare the predicted salaries to these real 6 salaries, okay? And we will do that in the last steps of this implementation when visualizing not only the test set results, but also the training set results. You're going to see everything will be super clear. All right, so let's do this. Let's get the test set results by first, in order to call a method, we first need to call the object itself, which is regressor. So that was the first step you had to do here. Then from our object, we add a dot here and we call the function we want. Oh, wow, it's funny. The Google Colab actually guessed what I was about to call. I never noticed that. But anyway, yeah, that's perfect. We want to use the predict method, of course. That was the hint. And this predict method, as any function, expects some arguments. And so now, according to you, what did we have to input in this predict method? Well, that's simple. Once again, we want to enter the features, meaning the numbers of years of experience, and not the salaries. That was just for the training set. Here we only need the numbers of experience, because from the numbers of experience we want to predict the salaries. And the numbers of experience are exactly contained in X test, right? Because we want the numbers of experience of the test set. And so the only thing we had to input here is X test. And there you go. That was the solution. Okay, so as you can see, once again, very easy. That's the beauty of the libraries. You can just do anything you want in usually 1 or 2 or 3 lines of code. And here, we just had to call the predict method to make some predictions from a model that is, of course, already trained on the training set. All right? Now, because we're going to visualize then the training set results and the test set results, I'm actually going to put all these predictions, because this returns actually a vector of predictions, a vector containing the predicted salaries of the employees in the test set. So I would like to put all these predicted salaries in a vector, therefore in a new variable, and therefore here I'm creating this new variable which I'm calling ypred, as opposed to ytest, which contains the real salaries. So make sure to understand ytest here contains the real salaries, and ypred here contains the predicted salaries. And now in the next steps, we're going to compare ypred to ytest, and also we'll compare ytrain to the predicted salaries in the training set. And the last 2 steps of this implementation, visualizing the training set results and visualizing the test set results. We will get amazing graphs, super clear, super simple to understand, and we will clearly see how well our model was trained with this visualization and how well our model was able to predict new observations with this visualization. All right, my friends, are you ready for the final steps of this implementation? First, we're going to visualize the training set results, and second, we will visualize the test set results. So let's do this. Let's start by creating a new code cell, and there we go. Now we just want to plot on a nice graphic the real salaries compared to the predicted salaries. So basically we're going to have a 2D plot with the x-axis being the numbers of years of experience, from 1 to 10, and the y-axis being the salaries, in the range of salaries given in this data set. And so we will plot in red points the real salaries and in a blue straight line the predicted salaries, okay? And we will do that both for the predictions in the training set and the predictions in a test set. Are you ready? Let's do this. We're going to first call matplotlib. As a reminder, it has the shortcut plt. Actually, what we're going to call is exactly the pyplot module from the matplotlib library, and this is what is having the plt shortcut. So there we go. Let's start by calling pyplot plt, and then we're going to call a specific function from this module, which is called scatter. And scatter will allow us to put the red points, corresponding to the real salaries in the 2D plot. Okay, so naturally what we have to input here are the coordinates of these red points representing the real salaries, and these coordinates are nothing else than x train and y train, right? Because remember, the x-axis will be the numbers of years of experience, that's what is contained in x train, and the y-axis will be the salaries, and that is what is contained in y train. So here, in scatter, here we just have to input the coordinates. First, x train for the numbers of years of experience, there you go, and then y train for the salaries. Okay, and then we can add another argument, which is color, and which will allow us to choose a color of these points. And as we said, we're going to choose red. Perfect. Then, next step is to plot the regression line. So remember from the intuition lectures, the regression line is the line of the predictions coming as close as possible to the real results, to the real salaries. And therefore, the predictions, the points corresponding to the predicted salaries will follow a straight line, right? As in a linear function. And therefore, here we're not going to use the scatter method, we're going to use the plot method, because that's what we use to plot the curve of a function. And since our function is linear, it will actually be a straight line. All right, so there we go. Let's call first the PLT module, pyplot. Then from this module, we're going to call the plot function. There you go. And in this function, well, same as in the scatter function, we have to input the coordinates of the point or line nodes corresponding to the predictions. So let's do this. According to you, what is the first coordinate of these predicted salaries? Well, that's of course x train. Why is that? It's because right now we're visualizing the result of the training set. Okay, so these corresponds to the numbers of years of experience of the employees in the training set. That's the x coordinates. Okay, now we're going to input the y coordinates. And according to you, which ones are these? Well, it's something we haven't created yet. We created actually the y-pred variable containing the predicted salaries of the test set, but we haven't created a vector containing the predicted salaries of the training set. And that's totally fine. What we'll actually enter here as the y coordinate of this plot we're about to make are going to be exactly the predicted salaries of the training set. And to get them, I'm going to copy this and paste that right here, but instead of inputting here x test, I'm going to input actually x train, because calling the predict method on x train, meaning on the numbers of years of experience of the employees in the training set, will get me exactly the predicted salaries of the training set. All right, just as before with predict x test. So x train, yes, and then just as before, we're going to choose a color, which this time will be blue, right? So that we can clearly see the difference between the real salaries and the predicted salaries. Okay, so this will plot the regression line. Now, next step, what can we do? So here we're gonna add a title, and to do this, we have to call the title function, and inside, in the parentheses, we just have to input in quotes, well, the title we want for our graph. And so let's say salary versus experience. Okay, you can choose any other title if you prefer another one. So salary versus experience, and then we're going to specify the training set, because indeed then we'll do the same for the test set. Now we're just going to add a label to the x-axis and to the y-axis, and for this we have to use the x label function, into which we have to input, well, the label we want to display on the x-axis, and we're going to choose, in quote of course, years of experience. All right, good. Now we're going to copy this because we're going to do the same for the y-axis, and the name of the function for this is y-label, and for the y-label, well, we will choose to display salary. Okay, and finally, in order to show the graphic, well, we just had to finish here with plt.show, the show function, and this will display the graphic in the output. All right, so good. Now we're going to do the same for the test set results. So I'm just going to copy everything here and paste that in a new code cell right here. And so now we're going to do the right replacements in this code in order to visualize this time not the training set results, but the test set results. And so obviously the first thing we need to replace here are the coordinates of the real observations, because these are the coordinates of the employees in the training set, and we want the coordinates of the employees of the test set. Therefore, here we have to replace obviously x train by x test, and then y train by y test. Okay, so these are for the real observations with the numbers of years of experience and the real salaries of the test set. And now, according to you, do we have to replace something here? In PLT plot, xtrain regressor dot predict xtrain. According to you, do we have to replace xtrain by xtest and the same xtrain by xtest? Well, that's kind of a trick question, because remember that the regression line that we get is actually resulting from a unique equation, and therefore the predicted salaries of the test set will be on the same regression line as the predicted salaries of the training set. And that's why here we actually don't have to replace xtrain by xtest here and here, okay? You would actually get the exact same regression line whether you plot the coordinates of xtrain and the predicted salaries of the training set, or xtest and the predicted salaries of the test set. You can check, but that's because the regression line in a simple linear regression model results from a unique equation, and we therefore end up with the same regression line. Okay, so no need to replace anything here. And finally, we will just replace here training set by test set. And there you go. Now we're ready to visualize the training set results and the test set results. So let's first run the cells we haven't executed before. So remember, we executed up to the training. So now we have to execute this one to indeed get the vector ypred of the predicted salaries of the test set. So there we go. We now have ypred. And so now we're going to first execute this to visualize the training set result. And we're going to obtain now a nice 2D plot with indeed the real salaries in these red points here, and of course our beautiful regression line containing the predicted salaries. And we clearly see that this regression line was calculated so that it comes as close as possible to the real salaries. And of course, for each of the years of experience here, in order to get the predicted salary, you have to project the year of experience to this blue regression line. So for example, the predicted salary corresponding to 8 years of experience is about, $100,000 per year. Okay, so that's how it works. And so we can clearly see that our predicted salaries are very close to the real salaries, for most of them. But that's on the training set. Remember, that's important because our model was actually trained with these observations, with these years of experience and salaries. Now, what we would like to observe is if we have the same result, the same closeness of the regression line to the real salaries in the test set with which the model wasn't trained. We want to evaluate it on new observations. And that's exactly what this new graphic will tell us, because now we're about to plot, this time, the real salaries of the test set and the predicted salaries of the same test set. So there we go. Let's run the cell and let's see if we're still close to the real salaries even for new observations. And yes, absolutely, our predicted salaries, which are of course on the blue line once again, are very close indeed to the real salaries. So our model, our simple linear regression model, was able to do a wonderful job at predicting new observations. So congratulations, that's very exciting. You built a very successful first machine learning model. However, just remember that the reason why we get such a good regression line here is simply because there was a linear relationship in the dataset between the features and the dependent variable of the dataset. In other words, we had a perfectly linear dataset. In other words, we had a dataset with linear correlations. And what I want to make sure you understand is that these beautiful results won't happen for any dataset, because of course you'll get to work on datasets with nonlinear relationships, and for these datasets you will need a nonlinear model. And that's exactly why in this part 2 regression we will also study some nonlinear models, which you will see will be polynomial regression or SVR, which will allow you to get amazing results for datasets having nonlinear relationships. But for this dataset, we clearly had linear relationships, and that's why a linear regression model was perfectly fine, but I just wanted to highlight this. Okay? So congratulations once again. I hope you're very happy and excited to have built your very first machine learning model. Now we're going to increase the difficulty a bit, because in the next section we will build a multiple linear regression model, meaning that instead of having one feature, only one independent variable, we will have several of them. And that's exactly the difference between simple linear regression and multiple linear regression. Simple linear regression is when you have only one feature, and multiple linear regression is when you have several features. So take a good break now, and as soon as you're back with your energy, let's implement our second machine learning model in the next practical activity. And until then, enjoy machine learning.